Hello, everyone. I'm Esther Urlus. I'm founder of the Filmwerkplaats. I'm one of the members. The Filmwerkplaats is an artist-run film lab in Rotterdam, and we are an association with members. I'm one of the members, and I will give the lecture number 2 today. This lecture is in our new project, the Photographic Garden. The Photographic Garden is a series of 6 lectures and research workshops. These 6 lectures will be all online and will be recorded and will be put on our Filmwerkplaats Vimeo account afterwards. The Photographic Garden, the title we took from Ricardo Leite, who's also going to give a lecture next month. And the whole idea behind this project is questioning the way of environmental consciousness within the analog and photochemistry film. And it's also a kind of search to new artistic ways to form an image. And for us, the labor-ness of how you work with the photographic processes, who are part, of course, of the analog film, give artists lots and lots of new possibilities, especially if you do it yourself. And I hope also that you can shape everything to your own will. Besides that, we are also researching to make the medium more sustainable, both in environmental friendliness. So the next lecture by Ricardo will be about developing with plants. This time it's all about making your own light sensitive silver gelatin emulsion. One of my favorite parts, of course, in my own work. And we're also trying to find new ways of making images, and also in a way of making everything future-proof, but also in an artistic way that you really can make the image from beginning to end, so that you even are capable of making your own light-sensitive emulsion. So that's our Photographic Garden project. Today I want to talk with you about home brewing a light-sensitive silver bromide gelatin emulsion to be coated on 16. And I'm going to share my screen, and I made a PowerPoint presentation. I hope it will work and everyone can see it. And I want to show you all my research I did on this. And so let's start sharing the screen. So my research is really when I started wanted to make my own light sensitive emulsion for my 16mm films to be coated on clear film. I really went back to the beginning, to the pioneers of this medium. Although it was quite different from them, for them this was a new medium, and they wanted to make steps to go further and further to copy nature. I want to go backtracking to their in the beginning of their findings, because I wanted to have a material I can really form to my own artistic research and artistic use. And I have to admit, I just found out that this year, it's exactly 150 years ago that Richard Maddox invented the dry gelatin plates, which is to make pictures. And all this silver, bromide, gelatin, film emulsions are based on his findings. The picture you see now is the very first picture ever produced by Niapse in 1825 or 1827-ish. And as you see, it is the view from his window. But my research and my films are all about color. So my research was really is really interested in how to create color. And I know what you see now in the picture, I hope you see it, is actually a developed slit through of a piece of color negative. I knew immediately this is not the way I want to go. I'm not here to, and it's also not my research to make an image which is neat and precise and even. Then I should stay using what is already made. That always would be better. I'm having a little troubles with my screen, sorry. So I knew immediately this is a no-go area for me. This is also not what I want. My research, I knew I had to go to the beginning. I had to find options to create my own emulsion. And then go back to the early ways of making color in your film. But then I first had to find out how to make my own light sensitive silver emulsion. I'm going to tell you a little bit about how in chemistry and process this silver gelatin emulsion is working, because it makes you understand a little bit more about the research I did, but also how it works. And even if you are in the end think, well, making my own emulsion is not my cup of tea, it's fine. But I do think for every filmmaker and photographer working with analog or light sensitive and photochemistry, film and photography, understanding this, how it works, will make it more understandable why certain reactions are happening. So if you work with film, you have a base, and this is plastic. Most of the time it is, of course, acetate or polyester, and on top there is emulsion. But I have to go back. I'm going too quick to the next step, because I want to first show you a little bit about my interest in the first steps in the pioneering way of creating color with film. I always think with film, and then especially analog film, the beauty of it in color, it has actually two ways of creating color and color mixing. It is the additive one, so you mix 3 colors and you get whites, or the subtractive one, which you mix 3 colors and you will end up with dark, like in paintings. With film, you basically do both. A negative is a subtractive way of color mixing, and in the end, a positive is an additive way of mixing color. But this way of thinking about color also gives you ways to create color actually with black and white film. So this is the very first image, a photographic image of color created by James Maxwell. And it is a color ribbon, so something you put in your hair. It actually should be flipped. And I flipped the image, but then I saw that the next image, which one explains how color was created, it was also flipped. So this is actually you're watching a black and white picture. But this black and white picture is divided in 3. So actually he didn't make one picture, he made 3 pictures. And he made 3 pictures by making a picture with a red filter, a green filter, and a blue filter. And after that, he had these 3 negatives, or 3 positive, and he combined them also with this red, green, and blue. And then he created this image. So basically, you're watching 3 positive black and white frames. To show it a little better, it's this beautiful picture by Gorski from 1911. And actually here you see the 3 positives who together create a colored image. So these were ways to create color without being able to make a color negative material on the base. And I knew for my own research, I preferred to go in this stage because this gives me so much artistic freedom, because I can change in between with the positives and start. This is a tremendous artistic freedom it will give you if you just stay on the black and white. Although there is a little detail I forgot to say, which is really important. To be able to do this, to make 3 positives or 3 negatives and make it later a positive, seeing red, green, and blue, it means that your black and white emulsion you're making also should see these 3 colors, red, green, and blue. This is another example of this 3 color system. So you have a black and white film, and with this you create color. This is for me, one of the most inspiring ways of making color on your film, well, photography. This is an autochrome. Autochrome was invented by the Lumiere brothers. And it's really like 1903 that they really patented as an amateur photo medium. And what they did is they made a black and white emulsion, and then the idea was that you would reverse this black and white emulsion in the process. I hope you all know this. You can reverse by developing your black and white in a reversal process. But to get these colors, he also used color separation, but then with potato starch. So he colored a potato starch in red, green, and blue. Although at that moment, they didn't use really red yet. They used a kind of orange red, because they were not able to make an emulsion at that point that was sensitive for red. It was sensitive close to red, to orange, but not red yet. And actually it gave almost paintery colors, which was beyond nature. The pioneers at that stage wanted to copy nature, but my artistic research, I love this image. I did some tryouts, but okay. here comes the explanation bit. This is the wavelengths of color. On top, you see all the wavelengths, which are from really like 10 to 1 kilometer. And then in the middle, you have the colors, at least what we see as humans with our eyes. It started really to purple bluish, and it ends in the further wavelengths to red. This is underneath, what you see underneath is what we see with our eyes. And it also means that if you make an emulsion, even if it's black and white, you want this, that your emulsion is capable of seeing all these colors. Because if it would not see a certain color, which is most of the time at the end of the longer wavelength, so red, it would mean that everything, if you make a picture of something which is red, it will not see it. It will stay blank on the negative, so black on your positive. Basically, the first ever simple black and white emulsions were so-called colorblind. They see color, but very slowly, and what they especially see is the shorter wavelengths, so purple, blue, maybe a little green, but not that much. It also means that if you are working with black and white stock, and especially print stock for 16, and you can use it in red light, it means your black and white film is not sensitive for red light. These have, of course, names. A very simple silver emulsion is always blue sensitive, so it always is daylight film. If you want to have a film which is also sensitive for green light, you have to add additive synthesizers. A film which is also sensitive for green and a little in the yellow is called orthogrammatic. And then the films we buy from Kodak or from Orvo or Lucky Film, whatever, most of the time, if you put them in the camera, the black and white films are so-called panchromatic. So they're sensitive for the whole range of what our human eye can see. So also for red. Here you see it again in the wavelengths. The emulsion I want to show you today, the very simple silver gelatin bromide emulsion, is basically colorblind. If I want to make it sensitive for green, I have to add a dye, and it's always the opposite dye in the spectrum of the color you want to make it sensitive by. So if I would want to make an orthogrammatic film, a film which is also sensitive for green, I would have add a magnetic color dye. Here you see the erythrosine B. This is the one who is also in factories and nowadays films, or at least by the pioneers, used the most to make it orthogrammatic. If I want to make a film which is even more sensitive to more colors, even to red, I have to add a kind of cyan color. And underneath you see the pinacyanol fluoride, which is also used by pioneers. Knowing all this, I did some tryouts, but then I found out while trying out a huge problem. Because if you make your own light sensitive emulsion, the biggest problem is not making it. That's actually quite easy. It's as easy as making mayonnaise, but then in red light. But coating it evenly on a little 16 mil clear film, that is the big difficulty. So I thought, if my film will be panchromatic, it means I have to coat my film in total darkness. So that is a no-go area for me on this moment. It's something I still have to tackle, how to deal with this, because I am still making handmade emulsions, and I will show you in the steps, really step by step, so you can also do it at home because it's really fun and it gives you a lot of more possibilities. But the panchromatic, for me on this moment, that research I stopped. Worldwide, there are a few artists working with 60mm film and making their own emulsions and doing some research. I still hope that in the field and maybe in the future, one of you is going to work and is interested in this panchromatic, so sensitive for the whole color spectrum from blue to red. Maybe out there, one of you is going to do this. Please share it. Please share everything you do in the network for free, like the pioneers, because film and emulsion research, in the beginning, it was shared, every research was shared openly. The French government in the beginning, in end of 1800, beginning of 19, put a lot of money to have all these amateur scientific guys, everyone to research this, so it could get on a higher level. And for artistic research, I really think we also should openly share your findings and spread it and have it available. So that's one of the reasons to show at least my findings. So we're going back to the beginning. Today I want to show you step by step how to make this simple, light sensitive, basically only for daylight or for blue light, but usable for both printing as a little bit in the camera. Coating. How to get it on your 16 clear film. These are some ways I found in books from the pioneers. And at the left, you see some coating machines. If you work with gelatin, gelatin is a very, very special ingredient. I have to say something about gelatin, yes. Gelatin is coming out of the meat industry, and it's a byproduct, a leftover product. Gelatin was found as a kind, is used as a kind of glue. So it keeps your mixed silver halides glued on plastic. Normally, plastic is not a very handy thing to glue things, but the gelatin will make it glue on this plastic. And there's another thing not many glues can do. It will stay together in fluids, because if you have your light sensitive, you also want to process it. So developers should go fixer, washing, and the gelatin should not dissolve, it should stay there. But it also should not be that no fluids can enter. So it should be open enough or porous enough to allow developer and fix enter and change the silver halides exposed into silver metals. All this. And then there is another very important part in gelatin. When the pioneers started to work with gelatin, they found out that, that every batch of gelatin was different. Every time they used gelatin, the sensitivity of their emulsion changed. Gelatin at that time was most mostly, at least the one they used, made from cow skin and cow bones. And the proteins in cow skin have a lot of sulfur and other minerals. And these minerals and additives in the gelatin actually gave the gelatin to be a kind of sensitizers. Not in this way, but really in, in the way of making it more light sensitive. Because the emulsion I'm going to show you how to do it at home will be a 1 ASA. I'm not know if everyone is familiar with light sensitivity of emulsions, but 1 ASA is similar to a nowadays standard black and white print stock, like the one you buy from Kodak or Filmotex or Orbo is around 1 ASA. You can put it in your camera and you can film with it. But to get an emulsion at home who is more light sensitive, you need to put additives. This is a little bit my research on coating and developing. Oh, I'm missing one picture. I go back, sorry. So about the light sensitivity of your film is you have to add small amounts of additives to make your emulsion more light sensitive. In the emulsion I'm going to show you, we're not going to do that. But these additives to put, like a little sulfur or ammonia, you can always add at a certain point just before coating. Also, if you want to make it panchromatic, you do it in the step just before coating. So you could even make, but if you want to use sensitizers, don't use the emulsion, the first emulsion I'm going to show you. Use a washed emulsion. I go step by step through all this. And I will explain you a little what is happening and what you can do. So coating. Nowadays, I coat always with an airbrush. Other ways are just with a brush, a sponge. You have to find out what is your best. But today I'm going to show you to do it with a small airbrush. This is not a fancy airbrush for artistic use. This is often a very small airbrush used to paint model trains, or the good thing, it's also cheap. This is in short a little my first research on handmade emulsion, and this is also a little bit what I'm going to show you what you can achieve with the emulsion I'm going to show you. It also gives certain color options, but then again, really like the pioneers, not making actually color film, but really use tinting and toning processes to change the silver color of your emulsion, or to tinting that you change the clear film. So we're going to start to homebrewing a very simple silver bromide gelatin emulsion step by step. And I call this a very simple silver bromide gelatin emulsion because the emulsion will be only daylight sensitive or blue light sensitive, a little to the green. And you can make it almost in half an hour and start coating. Coating is still the biggest challenge. this is a start. I've chosen to give you possibilities to really start from the beginning. This is a kind of making emulsion for dummies. This will not fail, I promise you. And like the pioneers, not much is needed to make this one. You only need a few components and chemistry. You need a pan to heat up water. So you also need a small stove. And for the rest, the gelatin we're going to use is not the official photographic gelatin, but we're going to use food gelatin. Food gelatin, the fun of food gelatin is you have no clue where it's made of. Although I know this one is made from fish skin, not cows, fish skin. But what is still in there and the impurities, still I'm always happy with the emulsion if I make them from this one. Photographic gelatin is purified and graded, so it's always the same. If you want to use or make an emulsion with additives, so with sensitizers, or for sensitizers to make your film more light sensitive, or sensitizers to even make your film maybe panchromatic, use this one, because then all your experiments, at least there is no variety in the gelatin, because what I said, the gelatin is important, especially the dirty one. It can give you a higher or lower sensitivity and you have no control. Well, the photograde will give you control. If you're going to buy silver nitrate, keep in mind and shop around on internet, because in some countries it's very expensive. There's of course always the silver price and the silver markets, but I get my silver from France. So here we are. All this is recorded, so if you want to find back, you just have to later on can watch it back on Vimeo. So a very simple silver bromide gelatin emulsion. You have solution A, which is gelatin. With food gelatin, we're going to use it, and potassium bromide. Potassium bromide is also used in developers. So if you make your own developer, you should have it at home. And I always use distilled or demineralized water, whatever, both are fine. Don't use tap water, because in some countries they use fluoride in tap water, and chloride is also a salt which gives sensitivity to your silver nitrate. So use distilled or demineralized water. And for solution B, we have silver nitrate and also, again, of course, demineralized water. And to prepare these two solutions, you can still do it in normal room lights, only when you mix them together, you have to do it in red lights. Here we use tube lights with a red filter around it. It works. So now you see a little videos. I made everything. I made this emulsion already 2 days ago. And so I made a video of my steps because somehow I cannot do it with the computer. First of all, I want to show you that rinse everything with distilled and demineralized water. Just to make sure. What I also do is boil some water and clean everything very good with this hot water and dry it out. And then after it's almost cooked out, I rinse it once with demineralized water to avoid that there are little particles of other chemistry in it. As you see, I'm using stainless steel containers. These are Kinderman tanks. They're found secondhand. These are photographic developing tanks. They're small. I have one here. They're small. And if you put the lid on it, they're also completely light tight. And because it's metal, you can heat them up in a pan with water, which I do au bain-marie. So first you have to mix separately. You can do this in normal light, solution A, which is gelatin, the food one, the potassium bromide, and the distilled water. I repeated it a few times, so it's always easy to find back if you're watching back the video. So I use, in the end, I'm ending up with 125 milliliters of water, and I divided it in 65 for the gelatin part and bromide part. If you work with gelatin, and you have to work with gelatin, it's very important that, so you see 10 grams of gelatin, the food gelatin. This is another brand I still had somewhere. This is often found in the United States. So 10 grams. Gelatin have to let swell in cold water. So I don't heat it up at this point, but I just give it time to swell. And I show you this video so you really can see what is happening, so you don't feel unsecure in what's happening. But to avoid clutters in your emulsion, it's very important that the gelatin swells with water before you start doing dissolving the potassium bromide. This is how it looks when your gelatin is completely taken the water. As soon you see this, you can put it in au bain-marie in the water bath. So I use a pan on a hot stove, which is just around here in the dark room. It's handy because a lot of electric equipment has little lights everywhere. Check them once in darkness to see what color of light. If there are blue, really make sure it's covered. Also, all the equipment you're having, it's handy if, like we're going to use a thermometer. Some thermometers gives light and they give blue light. At one point, I even used the fridge, and we actually took out the light bulb from our fridge in the dark room. So if you by accident open the fridge while you're working in red light, it will not give this heavy. All these little things you get familiar with as soon you are in the dark. So as soon the gelatin is swell, I put it in a pan with hot water. I never check the temperature in the tank itself. I mean, in the gelatin or in the emulsion itself, always next to it. This is just to avoid contamination in between different pots, and also cleaning is not my favorite thing. So to avoid that, when your thermometer is still dirty, that you will put it. It also means that if you need it to have it at temperature around 50 inside the emulsion, the water outside should be close to 55. The first step of the gelatin is that you heat it up till around 50, and it should be dissolve, and it should be a kind of yellowish clear. The food gelatin always have this yellowish color, and you see a little in my gelatin that I have a little foam and bubbles. Try to avoid this as much as possible. But at the other hand, this is also about a kind of let it go and let yourself surprised with happy accidents. Because my whole research on this point was about happy accidents. So as soon the gelatin is dissolved in a temperature of 55 in the water bath, and you see it's now completely clear, then I add the potassium bromide, only then. Potassium bromide is 8 grams, while you use 10 grams of gelatin and 10 grams of silver nitrate. The mass of potassium bromide is slightly different than the silver. In the end, the idea is that the silver nitrate connects to the potassium bromide, and then the silver to the bromide, and it makes it a silver halide. Silver nitrate has on its own, it is only light sensitive if you connect it to this salt. And this salt, the best salt to do that, to get the highest sensitivity, is potassium bromide. You also could use chloride, sodium chloride, but then you get a much lower sensitivity. So if you're working with film, you almost always have to use the potassium bromide. Potassium bromide, 8 grams. The idea is that silver nitrate and potassium bromide make form silver bromide particles. The bigger and better these silver bromide particles are, the more sensitive your emulsion will be. So make sure it is 8 grams. I'm just showing you this because it was 8 grams. And then you can put it in your gelatin, dissolved gelatin, and it is still like 50 degrees. And make sure the potassium is completely dissolved. Potassium bromide is a kind of salt, and after a while it should be white crystals. If you have your potassium bromide too long, it gets a little grayish. Don't use it anymore. But it always clutters at some point. You can still use it, but it will dissolve slower. So make sure all particles are completely dissolved. Okay, and then we make solution B, which is just the silver nitrate, 10 grams with distilled demineralized water. You still can do this in room light. So you have, I use 60 milliliters of demineralized water, and I use it in a different, so I end up with 2 of these containers. It's also, if you taking out chemistry out of the original package, try to avoid that you have to put things back. And also use clean cups. It's fine if you use reusable cups, but make sure that you have a kind of color code, that every color has always the same ingredients, so there is no contamination in between. Try to work clean. Also use different spoons for different chemistry, and try to avoid that you throw it back in the original container, because it could be some pollution happening. The silver you can dissolve already in cold water, but it goes quicker if you heat it up till around 40 degrees, or you just put it. The problem is I never dare to put it next to my pot, which is still in the gelatin pot, which is still in the pan in the water. Before I put this container next to it, I always make sure the light is out. It's just to avoid things that can go wrong. I like happy accidents, but only in a controlled and way. So next step must be under really in red light. Now I'm going to show you the beauty of what is going to happen if you add the silver nitrate to your gelatin bromide solution. You add the silver to the gelatin bromide. So I end up with two of these containers next to each other. The one you're looking at now with the spoon in it is the gelatin one. You see it also, it has a little foam still around it. And this part has actually its own name, and it's called the emulsification. So there is a theory that the slower you add your silver to the bromide, the bigger the grains get. And in analog film and photography, the bigger the grain, the more light sensitive. So the idea is that the slower you do this, the higher sensitive your emulsion will be. Also, if you keep it around 50 degrees, also this temperature will increase the size of your grains. And now as soon you put the silver to the bromide, it starts to get milky. And you see there's a kind of cloud forming. Of course, in red, you don't see it, but the color is yellowish white, really like print stock, the color of print stock, which is yellowish whitish. This is just a few drops. And what is happening is that silver nitrate and potassium bromide, the silver is connecting to the bromide. But it also means you have still particles of nitrate and potassium there. It's important that you really at least try this amount is like 125 milliliters, so your emulsion amount will be around 125 milliliters of emulsion. I always make small amounts. It's also it's often enough for my projects to make more, I call this, so I make small amounts, I coat, and then again, I make new emulsion and I coat again. This always gave me somehow artistically gave me more than making a huge amount, like 500 milliliters, which I call a huge amount because it means that you need like 50 grams of silver, which is quite costly. But also the fun is actually you can change already at this point. So this emulsification point, you actually already can change how your emulsion will look in the end. So there is a kind of control on contrast in this. Because now I'm showing you, well, it's not in the video. I'm not going to steer 10 minutes. I cut it out. And actually, no. So 10 minutes will give you a higher sensitivity and slightly lower contrast. If, like me, you go like, yeah, this time I don't want to wait 10 minutes, or even if you would do it longer, it would be even better. So an hour, I did it once. It took me an hour just to drop by drop for this emulsification part. In theory, you should have a higher sensitivity, but this sensitivity is also mathematically. So maybe in this way, you could double the sensitivity of your emulsion, but double the sensitivity of your emulsion in this style with food gelatin and rather simple, no extra additives, no ammonia, no sulfur. Even doubling my sensitivity will mean I still end up with a 2-ASA emulsion, and still not a lot. So but it's still, what I would encourage you to play with this, because another method is that you do this emulsification in 1 second. So instead of dripping it constantly, slowly together, so the silver nitrate to your potassium bromide gelatin, you also could just throw it in and stir. It will increase your contrast, and it will increase, I found out, a lot, but your sensitivity will drop. But then, you know, if it would drop, it would, even if it would double drop, it should be like half an ASA. I use my emulsions basically only as print stock, not to put in the camera. So a drop of sensitivity is like 1 ND filter. I can handle this. Then you have something which is called ripening. And then you keep your emulsion on a constant temperature, so 50 degrees. I only check the water, I don't check the emulsion itself. 50 degrees for at least 10 minutes. Some do it even till 2 hours. My patience is not good enough to wait 2 hours because you have to stir now and then. The idea behind ripening is that it again increases your sensitivity, so that you give your silver halides the time to grow. And the pioneers did a lot of research in this state, so it really works. I normally wait around 10 minutes and then I'm done. Some do it really 2 hours. It will increase your sensitivity. So if you want to make emulsions which are suitable for putting in camera, although it's still low ASA, it could be wise to do some longer ripening. Okay, said that, there are 2 options from this point. So we've done this 10 minutes of ripening. Your gelatin is around 50 degrees. It's already an emulsion. It's already a light sensitive emulsion. So there are now 2 options you could do. One is it's ready to coat. So unwashed, nothing more. The other one is that you let it set, and then after your thread and you wash it. Letting it set, it means just gelatin. If you use gelatin at home for cooking, gelatin is used to get this jelly, firm, strong jelly that really glues together. This is called setting. Setting you close your little container, you close it like tight, and you just put it in the fridge. And it will be gelled in 2 hours or longer. Also, if you don't want to coat directly, it's also a way just to, you close your, that's why these are so handy. You close it and you leave it there. You put it in a fridge if you want to wash it, or you just put it somewhere and you prepare for coating. If you don't have these, don't worry, you can even do it in whatever pot or cup or glass, which is suitable to be heated up in a water basin, au bain-marie. If you want to put on the light on some moment, just put it, everything in a black bag and put it in your fridge. Just if you put it up so it doesn't fall, it will be fine. But you don't need special equipment to do this. I keep on saying this is really meant to do at home or to do it in a small dark room. Of course, you need a dark room, but also glass cups, coffee cups, everything is suitable. Although I'm not very happy with glass cups, because if it falls, it will break and all your emulsion is everywhere. Or sometimes you use the wrong glass and it explodes while heating it up, because not all glass can handle heat. All these accidents happened, at least to me. The little video I'm going to show you now starts first ready to coat. Afterwards, I also want to show you the setting, shredding, and washing. Ready to coat. I coat always on our table, which is in the dark room. The table is 2 meters. So if I cover this 2 meters with clear 16mm film, 2 meters is like 10 seconds of film. I tape the clear film straight with paper tape on the table. For me, this was always the most handy way to work with emulsion and how to coat it. I coat with airbrush, so I just airbrush the table basically. But also if you would use a paintbrush, it's handy if it's horizontal, because otherwise it will drip and be uneven. Some even coating, experiment in this, of course, but some even or not too thick coating could be handy, because if your emulsion is too thick on your clear film, the developer and the fix can no longer enter completely. So you would have black spots. I will show you some examples later on. So this is how I do it. The clear film I'm using, or I make it myself, or the last time I also bought it directly from Orvo, called TAC. I make it myself, or I use this one because this is not, yes, this is standard clear film, but it's special clear film because it already has a subbing layer. A subbing layer means that there is already an industrial made little layer of gelatin. Plastic and fluids together normally don't work that well. So this subbing layer is a pre-gelatin layer that makes it more stick better. So my emulsion will stick much better. Actually, the emulsion, if you would add slightly more gelatin, it actually also would stick to glass without a subbing layer, so glass plates, but it also would stick to a clear plastic without a subbing layer. But I use, and if I make my own clear film, what I do is I buy a leader film, again from Filmotech. They have emulsion or something called leader is rather cheap, and you can decide to develop it to black film or to fix it to clear film. So if I would just fix this leader, it is clear film with a subbing layer. A subbing layer is easy to find. If you wet it a little, the sticky side is where the subbing layer is. So if you put this clear film on your table, make sure that the subbing layer is facing up, because if you coat, it's there where the subbing layer is. As you see, it's clear film is clear film. I also use a dark table, which is very handy because I said that this emulsion, and you saw it, it's a little yellowish white. And if you have a darker table, you can see where you did coat, because although this emulsion is so-called colorblind, so only sensitive for blue light, it will fog if you leave it in very heavy. So you do it in red light, but dim red light, because you're working rather long in this red light. It should be dim light. So to find back, first of all, it should be really that it doesn't come up and doesn't be uneven. So I also use gaffer tape to make sure it's really, really strong added to the table. And then I also used paper tape to mark. Paper tape is almost the same color as the emulsion. It marks where my clear film is on the table. So I'm just showing what I do to make my emulsion making slightly more comfortable. So I do it on both sides. So as soon the red light is on and I'm airbrushing, I have a kind of clue where I should aim on. Airbrushing is a challenge, but it's not that big challenge. The biggest challenge is to aim, because it's just spreading. The airbrush I'm using is this very cheap Revell. That's my favorite brand, actually. I have more of these, but somehow this one I have already 15 years and it's still working fine. But if you use this airbrushes, it needs pressured air, or I don't know another title, pressured air cans or dust cans, and you just put your airbrush on it. Also, again, make sure also your container, because I always forget to clean my container, but that it's not contaminated with previous emulsion, because the previous emulsion, if you clean it in the light or you put the light on, is of course exposed. But now I did it just to show you what's happening in the dark. I really enjoy coating my film with this type of airbrushes. It's not only that I was able to make a very even, but it's also, it gives me special effects. I will show you some examples in a later state. But even with, also with a brush, a paintbrush, you can get beautiful results in coating. Another way is that you use a kind of coating machine. Kevin Rice made a small, he calls it the matte box, a tiny coating machine, and then it's really like the pioneers. It dips in the emulsion and the back is scraped off by a squeegee, and the other side is, I used it, but it was too even for me. So airbrush is my artistic tool for coating. So ready to coat. We go now back into the red lights and I'm showing you how to coat. If you work with an airbrush and this compressed air, you need to put it while coating it in a bucket with water, cold water. Compressed air, if you use it for a longer period, really the can itself really get icy. And to avoid that it gets too cold, you have to avoid it and you put it in a bucket with water, just cold water. And then there is another thing. What temperature should your emulsion have when you want to coat? This is, again, something you have to try and find your own way. And then every time you coat, it will be different. It's a trial and error way, and a different in temperature will give you complete different results. If you coat with a higher temperature, so around 50, and sometimes I forgot to check the temperature and my emulsion was close to 60, 70. Let's say 70 degrees Celsius is your maximum you can give your gelatin. If you go too high for too long, the gelatin loses its velocity and its colliding glue possibilities. If you go too cold, like close to 30, and with an airbrush, the air is very cold. So at one point it starts to set. It could be that you get clutters. So it is also the higher temperature you coat, it will spread out more on the surface of the clear film. While hitting the clear film, it will spread out a little. If your emulsion is colder, it will not spread out that much, but just stay on the spot where it hit in drops. And it could even happen that you maybe get bubbles. This is actually a part of the fun. It's up to you to do it. Only if you're using an airbrush, this type of little airbrushes, if you coat too cold, it could clutter in your airbrush while airbrushing in the dark. And then you have a big problem. Especially in the beginning, my emulsions were always too cold or close to cold. And so around 30, 35 degrees. And then my airbrush got cluttered. And it's really frustrating to have a cluttered airbrush while coating in darkness, because you cannot just step out and put on the light. You're in darkness. And all these little things. I use a pipette to fill the container of my airbrush. It goes slow, and sometimes if the emulsion is already not too hot, I leave the container in the hot water to avoid that it already starts to set. The set is this when the gelatin gets jelly and firm. And then I put it in on the airbrush. Always make sure you have a paper towel or something, because it will drip a little. It could be handy maybe if you practice a little in the light with some water with your airbrush, but it's up to you. Or you do it by brush. Here you see my compressed air and the bucket with water. And then I immediately start coating. And I just go slow from left to right and back. This is a little bit the speed. We've used a little torchlight with a red filter to show, but you see already that it gets a little layer. And because our table is dark, you can see somehow a little where you are. It can be quite handy to have a torchlight with little red lights. Don't use a LED light or a LED light because they're often too firm, too strong, and it will expose your film. Even if it's red, it's so intense, this light. So use a rather old-fashioned, or if you cannot find an old-fashioned lamp torch, then just add some paper tape in front of the light and then your red filter. Any red, dark red filter will do. Don't worry about the color type. So after, oh yeah, I have to say that with one filling of this container, we made 125 milliliters of emulsion. Normally that's enough for around 40 meters to 60 meters of film, depends on how thick I coat it and how even. For this amount, these are 12 strips of clear film of 2 meters. So we end up with 24 meter coated film. I filled this little airbrush container twice, and I still have, I think we're just halfway, maybe even less than halfway. So in the end, it looks like this. So now everything is coated from right to left. It can happen that at the edges of it's slightly less coated, but it's, yeah, we're not making a substitute for industrial film. It will never be even, and that also should not be your goal or your aim. Your aim should be a kind of tactility and that you use it almost as a need, that you can knead your material, and so it's a complete different approach, and it will always be unique. Your film will always look, your coated film always will have a slightly different look every time you coat, because there are so many variables. You have to deal with the temperature of your emulsion when you coat, the tool you use to coat, but this is for me where the fun starts. So, and then you have to let your emulsion dry in darkness. You have to put out the red lights, because if you would leave the for overnight, so I coat often at the end of the day, and then I leave it till the morning next day, and it will be absolutely dry. If you coat it with a brush and you use a soft brush, so if your emulsion has thicker parts, it could happen that it's here and there still a little moist. If you roll your emulsion on a bobbin, make sure it's completely dry, because otherwise it will stick together. Then let it dry longer. We are in a situation that we share the room with a lot of members, so I always make sure they know not to enter to avoid unhappy accidents. Okay, this is option 2, because now we have coated, but now we go back to where we were left after the emulsification and the ripening. So the emulsification, you put your bromide together with your silver, drop by drop, or quick if you want high contrast, low ASA. The other one is that you have it set. Setting is done in the fridge, it will be jelly, and then shredding and washing. It has some pluses to do this. First of all, if your again your silver nitrate and your potassium bromide made silver halides, there were so silver bromide halides. There is still nitrate, which is rather acid, and potassium left in your emulsion. So particles of this. If you use already also some ammonium, because it can give you a higher sensitivity, ammonium you put in your emulsion, because there are many different emulsion recipes. The one I'm showing is the very simple one. If it says ammonium in your first, in the emulsification added, then you always have to wash because you want to get rid of the leftovers in your, where it didn't connect. Another thing, if you want to use sensitizers for hiring the speed of the light sensitivity of your emulsion, you also should wash your emulsion. So that's why I also made a video of the leftover of the emulsion, which was not coated in the first time. The next day I made a video of that that it's set and that I'm shredding and washing. So it's a longer video. For washing, I use the same pan. It's the same pan. And it's very, very, very important that you wash with a very cold water. You don't need to wash with demineralized water. You can use whatever tap water, but it should be absolutely cold. And when I talk about cold, I'm really, really talking about 2 to 5 degrees, water of 2 to 5 degrees. So I have put some buckets of tap water in the fridge. So I was sure that it was really cold. I checked the temperature in the red light and it was about 5 degrees. What I'm doing now, I show you the jelly. And as you see, it's really firm. I take it out and I put it in a cotton cloth, a cheesecloth, they call it. It's an open structure cloth. Wash it beforehand with some demineralized water to avoid some minerals or contamination. And then I break. I do the very simple one. Some use little machines to really make small threading particles. I do it just by hand and I make a kind of thing that looks like ricotta cheese. As long as the temperature is low, it will be absolutely firm and strong. The nice thing about gelatin. And then I really wash it. I pour on cold water. What I said, really cold water. Use ice cubes if your water is not cold enough. It's really preferable. It should not be coming over 5 degrees Celsius. I actually don't know in Fahrenheit, but you will find. So 5 degrees Celsius. And this washing, the official way is you pour it over, you can move it and you let it stay there in the water for some minutes, and then you make sure the water goes out. The handy thing with this cloth is you can really take out the water, and that you do this like yeah, quite sometimes. Well, otherwise you get a halfly washed. So the finer your ricotta cheese emulsion is, and the more often you wash it with this cold water, the more likely all the excessive salts and potassium and everything is still there. Because you want to end up with pure silver halides, so silver bromide halides, and that all the parts that didn't connect, or the nitrate that separated and the potassium. After, well, I don't do it 10 times now, but after this, you just put it back in the container. You make sure that all the water is out, and then you can put it back in the fridge for a later state, or you heat it up again in your pan or bain-marie till it is it's fluid again, ready to coat. Okay, then you have a state which is called digestion, and this only makes sense if you would have a washed emulsion, the one which is now shown how I do it. So this is a kind of after ripening. So you heat up your emulsion in a pan at 50 degrees. Some do it at 70. 70 is really the maximum, because if you would heat it up for a very long period on 70 degrees Celsius, so 158 Fahrenheit, it could fog. I have to admit, personally, I skip all these, and a lot of my emulsions I use in my films are unwashed or just washed and heated up for coating. I skip the digestion, or actually, while heating it up for coating, it is a kind of digestion. The idea again is to increase the sensitivity, the light sensitivity of your emulsion. If you want to add additives like a hardener, anti-fungi, antibacterial, stabilizer, sensitizers to make it panchromatic, so also sensitive for red light, or autochromatic for green light. This is the point where you would add them. At the point just before coating, when it's heated up, so at the end of digestion. I also have to admit, I tried a few times. I really tried to make panchromatic because it would give me the possibility to do a color separation, like the pictures I showed in the beginning. Now I stopped. It's I have to work too clean, too precise, and I really have to do always the same. Because then you know, you can learn from your mistakes and accidents and know where to go the next step. For me, it's too scientific and too precise. I like quick and dirty emulsions. So I'm now more in the unwashed and what's happening if the emulsification goes like 1 minute or 2 seconds. But I'm showing you this because you can make the choice. Oh. Digestion, what I said, it should increase the sensitivity, the light sensitivity of your emulsion. If it's just heating up before coating, it's also fine. And then again, you are on the point to coat. Here the picture is. This is some research, well, some parts I did by trying to higher the sensitivity of my emulsion by adding some sodium thiosulfate. As I said in the beginning, that if you add some sulfite to your emulsion, you do that in the digestion state or the after ripening, you could really increase the sensitivity of your emulsion. And although I don't believe in homeopathic medicines, this is close to how little. drops you need to make it really, really more sensitive. The one underneath is really the so-called very simple emulsion, and then added a few drops, of course controlled exactly, but it's really like 0.00064% of thiosulfate solution. So you end up with almost nothing, and then add slightly more drops of this solution. So it's a 1% solution, and we went from 1 drop to 3 drops at the top. And then you see how it increased. This is a exposure with a sensitometer. So you always expose similar, and then you see what's with a kind of stop grade, and you see how it increased by just adding this sodium thiosulfate. Incredible. But you have to work precise and always use washed emulsion. Now we get to another thing. If you work like me, little chaotic and not always clean, and so this is what happened 2 days ago. Silver nitrate is, besides it's silver and therefore toxic for the environment, silver nitrate is also corrosive, and it gives stains to cloths, but also your hands. So I had some drops of silver nitrate solution, so the water and the silver nitrate, and it stained my hands. I still have them. They will stay there for, if I'm lucky, 1 week. If I'm unlucky, 2 weeks. Some stains can take half a year before they disappear. So try to work clean and use good gloves. And otherwise, yes, you have silver nitrate tattoos. Another thing, what can happen with your emulsion? The emulsion I'm using, I don't put any additives, no hardener, no antibacterial, no antifungi. So my emulsion will, in the fridge, if I don't coat it, it will stay good for a few days till some weeks. I don't know why some of my emulsion rot quicker than others. You're working, of course, with gelatin. Gelatin is made from cow bones, so this is feed for fungi. What you see here is an emulsion that went bad. I opened the container, and it was, even although it was in the fridge, it was no longer jelly. It was fluid. So and the smell was awful. So I knew it gone bad. Still, I coated with it, and the coating was rather uneven because the gelatin didn't want to glue that good anymore on the clear film. But in the end, it dried. It also dried longer. I had to dry it really for 2 days. But in the end, it sat on the film, on the clear film, and I just rolled it up and left it for some years. I didn't even bother to put it in a black bag. I just thought, well, whatever, as a kind of example, as an example. This is all hand-coated emulsion, and well, it's now exposed. So I left it there, and then one day I just put it on the editing table and watched it, and I saw there were fungi growing in my emulsion, and they must have grown while it was still wet and then dried out. And you see a kind of entity in the middle and roots spreading out and then frozen in time forever because it dried completely. Fascinating, but yeah, happy accident. Okay. Then I need to tell you something about, I need to be quick, it's almost 5:30, about developing your handmade emulsion. It's very important that you're you can use whatever developer black and whites, but I would recommend in the beginning use D19 because it's a very strong developer, and it's important that your developer has a temperature of around 12, 15 degrees. You can make your own D19. It came a little gothic. I use any fix, any black and white fix, but I make sure my solution is 1:4. So it's rather strong. And before use, I put them in the fridge to make sure they are around 12 to 15 degrees. So 54 to 59 Fahrenheit. Because this emulsion, although if it's dry, it's really firm. This is airbrushed emulsion. It's really, really firm. But as soon wet, the gelatin swells again and gets very fragile. And if your developer is too hot, it will just the gelatin will just melt again. So make sure it's cold. Okay, then I want to show you some results of my first research ever. First of all, the first time I wanted to code with an airbrush, I went to the shop and asked for an airbrush. And it says, yes, we have, it's 350 euros. And I thought, it's just a test. I don't want to spend 350 to a professional airbrush to do a test with gelatin. I have no clue if it's working. So I used an air pump spray sprayer. So you have to put air in it and then you can spray. 250 in another shop. It was a disaster. But when I looked at it at the editing table, what you see is just gelatin bubbles. And the emulsion was fine because this is already developed. So developed and fixed. So in the end, I found this airbrush, which is more a paint brush, airbrush paint for paint, cheap. And I did my first test. My first test, I made a very thin layer. And that's why it's slightly grayish, because I was very afraid. This is my very first test ever with the little Revel airbrush. And then I also, because I was in my first research really thinking about to get control on the evenness of my image. And I really wanted a very neat, just for the research image. So I started to add some alcohol because I thought like alcohol will evaporate quick. So it will dry quicker because the faster it gels, the stronger your emulsion is. The layer was also slightly thicker, so it's really having an image, but it still has this airbrush structure. Okay, and then I added some extra water. So the idea was that it would spread better. And I also added some washing agent, A10, which is Agfa washing agent. The idea was that it would spread more evenly. And as you see, I think this is almost a perfect image. The original image is filmed with an underwater camera, a Super 8 underwater camera. And I enlarged it to 16 negative, and I printed on my handmade emulsion. And this is a picture still really from this handmade emulsion, original, but then as a print stock, so to make a positive. Yeah, of course, my work is about color, so I also wanted to use ways to color my film. This is toning. So I actually toned it. It says Caffenol Iron Toner. I also wanted to know if my emulsion was suitable to use with Caffenol. Oh, it's not here. Okay. Caffenol actually works. The problem with Caffenol, I don't know how many people worked with Caffenol. It has a developing time of around 15 minutes. And then it should be rather cold because of my handmade emulsion. So my developing was around 20 minutes, and the longer your handmade emulsion without a hardener and anything stays in a fluid, the more fragile it was. But it works. It worked rather good. I was very surprised, and my simple emulsion was strong enough to survive 20 minutes easily in the Caffenol. So it's very promising also that in the coming lectures that we learn how to develop with plants, your handmade emulsion, yes, can be developed in plant-based developers as long as you do it cold. So under preferable 15 degrees. This is with, after developing with Caffenol, I also toned it. So then you have to bleach it and then put it in an iron bath to make it blue. Another way is of coloring, which is more intense, is to color with color dyes, but then you have to bleach etch your emulsion first. This is all steps you do after you processed it. These are all things I did with my handmade emulsion. And I have to admit, it still surprised me how strong this simple handmade emulsion is, as long as you lower your temperature and make sure it never gets over 18 degrees Celsius. And I even thought that my emulsion would just disappear after a few years. That when I made a film out of this first research, and I even have some, if we have time, but I first want to do questions, if there are, of course. I'm always surprised how strong and how long it lasts. I'm at the end of my lecture. It was rather long, I know, but just look it back so you can go and do it yourself. I also made a booklet calling Reinventing the Pioneers. On this, you can get it from Worm, buy it actually from Worm, and there are still copies available. So if you don't want to watch the video, but just have it on paper, this is a way. So this was my lecture for now. If there is time, I want to show you some tests on film, but first I want to know if there are any questions. If not, yeah, oh, it says out of stock. Yes, the booklet, it's gettable at Underbelly. It says out of stock. Underbelly is just based in Worm. Out of stock, it means she didn't take it out of the box. There are still like 30 copies of this booklet available in the box. So if you would like it, just send her an email and she will get new booklets out of this box. If there are not any questions so quickly, I see here time and temperature for the D19 developer. Well, the temperature, what I say, it's very important to have a low temperature. So preferable 15. That's why I use D19, because D19 is still working at that low temperature. Normally developers, you have to work around 20 degrees. 20 is I wouldn't go 20 with your handmade emulsion, but 15 degrees D19. And I don't really have a time. I often develop my handmade emulsion in a Russian tank, but then in red light with the lid off, so I can see. If you would develop small amounts, like 2 meters, you could do it in a photo tray, and then you see in the red light if it gets dark enough. So it depends on the temperature. It can be 6 minutes, but it also could be 10 minutes. It has to do with the temperature, the thickness of your emulsion. It's all finding out what's happening. Also, for the fix and everything, also low temperature and fix, of course, you only can do too short, never too long. So to be sure, just leave it in for 10 minutes. And then if it's not fixed by after 10 minutes in a 1-to-4 solution, it means your emulsion was too thick, and the gelatin layer is too thick that it doesn't allow the fix to go into. It says, asks, when did you add alcohol, water, caffeinol? Caffeinol is actually a developer based on coffee. Sorry that I didn't explain. It's coffee with instant coffee, actually, with vitamin C and washing soda together. This is called caffeinol. So this is used as a developer. The alcohol I only did once in a test. I don't think it gives any extras. I thought it would dry quicker, because the quicker it dries, that's my theory, the stronger your emulsion will be. When it's dry to be used, it will scratch less. And it will also stay good for archives much longer. I think this handmade emulsion could easily survive 40, 50 years. I don't know if anyone is interested watching the test results, because otherwise I'm going to share the screen now. Oh, there are still some questions. Oh, I have to stop. Oh, where to buy clear film? I don't buy clear film. Well, I did. We bought this together with quite some artisan labs in the network. But the minimum amount of these rolls of clear film was 72. So we had to wait till we had enough people who wanted to buy clear film. This is also acetate based. Normally I coat on polyester just because it's cheaper and it's strong and I have it. This is acetate. So if you want to use it in a camera, it could be wise to use acetate. I've put my very simple emulsion coated film in a Bolex. It runs through okay. It's not that sensitive, it's like 1 ASA. But I was able to film on it. So this whole lecture was all about, do copy this at home or in your own lab. It's simple. it's fun, and it will give you so much new artistic purposes. Okay, and now I want to show you the test results of the pictures I showed you by sharing my screen and hoping it will work. It's not running really smoothly, but it's showing you pictures now and then. This is the results of the air pump. The black parts are the parts, I'm looking at another screen to watch. The black parts means the fix didn't go. And this is actually my first tryout with the airbrush, the little airbrush I'm using. And there was already some images going on. It was a little thin, but it had to do that I didn't dare to use too much precious silver, so I didn't coat it thick enough. And that you see constantly, you see like 10 seconds of film and then it disappears. It had to do that, that's the end of the table. So it was not coated properly, and then it made a round and went back on the table. Nowadays, I cut it and tape it before use together. So it's really, there's no in between. This is already, so you see what I showed you on the pictures one by one. I'm not always sure which one, but this should be then the one with the alcohol. The alcohol didn't do that much. I thought it would be a good idea. And also you see now and then I have more contrast than other moments. It all has to do that if it was hot for a long time, it get less. This actually was already at the end of the thing that I used a little wetting agent in it. What you see is a horse swimming, which is filmed with an underwater Super 8 camera. And I found a swimming pool specially made for horses and a horse to swim. And the cameras were just hung underwater. We had no clue if we would capture a swimming horse or not. Now you see the tests with the iron toner. So slowly, slowly it gets to blue. This is also iron toner. Because the gelatin is not hardened, it's a handmade gelatin. Also the gelatin colors gives a little color. I actually like it. It's clear, but with a little color. This is the methylene blue dye coloring, very intense. And I'm not sure, but I think I also have a methylene green. So this is also a dye toning. So this is like the Pioneers tinting and toning. Well, this is only toning. It all has to do that in my own work, of course. Yeah, it's based on color. I did some more research also for the ones interested on vegan emulsion, so that you have a substitute for your gelatin, which is based on bones of animals or skin. But then I found a patent from the 50s from a company called GAF in Germany. And there is a link in the chat to this research. I have mixed feelings about changing the gelatin into PVA, which is polyphenol alcohol, because polyphenol alcohol is a plastic. And gelatin is a leftover from the meat industry, which is again, not environmental friendly industry, I know, but it's a waste, a product of them. So, and it's the product itself, gelatin, is really environmental friendly in use. It doesn't, it actually feeds a lot of fungi and everything. So But the research on this PVA as a substitute for gelatin was really fun. So for now, if you have any questions, because I know it's a lot of information, just email to filmwerkplaats@worm.org. And I also want to end that the next lecture in this photographic, because this is all for the photographic garden project we are doing now at the Filmwerkplaats. The next lecture will be by Ricardo Leite, and it's all about developing with plants. Actually, he did make a photographic garden research some years ago in finding the most usable plants to be used as a developer agent. This lecture will be held also online and also free on 28th of August. So longer than a month. Thank you for being here. I'm leaving, I'm stopping my share. This video will be available on our Vimeo from Filmwerkplaats. So if you want to look it back and go slowly through it. I'm also happy to share everything I did. If you have more questions, just spam us on our email. Thank you.